So today's dev diary it's going to be pretty short, and we're just going to look at just an interesting little snippet about development, which is hunting down bugs. So in this case, one of the testers of the game reported that when they played one of the levels, they saw a very large glowing effect, pink glowing effect, when they used the brake power up on ice. Now, it's interesting because I did add a lighting effect to braking recently on top of an older lighting effect which I had in there, which is some sparks, which was meant to indicate, you're braking really hard. But I thought it made sense that all of the powers had like a light to show that they're active. So I added those lights and they all seem to be working fine. But all of a sudden I get this bug report. So you start thinking, okay, there's obviously some code that I've written that isn't working quite the plan. So let's have a look at the bug. Okay, let's go and see what the problem is. So there's the brake power up. Let's just go and get it. Okay, so the idea is that when we press B, we should get a nice glow to show us that we're braking. But let's see what happens when we go on ice. So it's very, very bright. Yeah. So that is not what we expect. Okay, so that's what we need to go and fix. Okay, so this is actually in the code, and I won't bother explaining everything about the way coding works, but we'll just concentrate on there's two what we call objects here, classes that actually do two different things. So you've got the player manager that controls the player. That's like how many points you have, what your mass is, things like that. And it's kind of a utility to control lots of things to do with the player. And then we have a separate class called the ball motion controller, and that actually applies your inputs to the player and makes the your marble move around, things like that. And you can see I've called it ball here rather than marble. Now, in the player manager, we have a method called glow brake light, and you can see it takes in a single floating point value called brake magnitude. And what it's designed to do is to modify the power light for the brake and to increase its intensity. That's what plus equal means. To take its current intensity, that's basically the brightness of the light, and add on the magnitude that you've passed in here. And I'm multiplying it by 1. That's so that I can actually modify that value if it turns out to be too bright or too dark. But in this case, it's just left as 1. So it would actually make sense in the end to remove that from the code. But I believe a lot of compilers these days will see something like that, where you've got a value that doesn't change, and you're multiplying by something by 1, and they will automatically just remove that for you. So it's not really a big issue. The big issue actually is that the magnitude that's being passed in here is very, very big, and that's why we're getting that really bright pink glowing effect. So this is actually where the that value is calculated, and I'll walk through how it's done, and then you can probably see why there's a problem. This basically is a file where I've got my old code, sorry, my new code. That's actually the fix for it. And I've got the original code here, which I've recreated for this video. So first of all, we need to work out how much braking is happening, because the brightness of the light is based on how hard you're braking. Yeah, so you can imagine it being a little bit like when you if you were in a Formula 1 car and you were braking really hard, the disc brakes would glow. Yeah, because you're braking really hard and all that friction makes the brakes glow. So I thought it made sense that if you measured how much the ball was spinning and then how much the ball was spinning after braking and compared the two, that would give you the magnitude of your braking, and then we'd use that to brighten the light. Then you have something that then drains away that brightness, and that then gives you the glow effect, and then the brightness draining away. So you can see here I store the rigid body, which is the physics simulator for the ball, and I get its angular velocity, and I work out the magnitude of it. I get the magnitude of it. So the angular velocity is basically how fast the object is spinning. And the magnitude gets that what's called a vector, and then it just works out basically how big the vector is without any sort of concept of direction. Yeah. So the velocity will actually have two things in it. One is a direction and how fast it's rotating in that direction. And what we really care about is just how fast it's rotating. So that's what the magnitude is. And that results in a float value, as you can see here. And then we then apply the braking, and that's to the motion through space and the angular velocity, because we found that worked best to make your marble slow down. And then what we do is we compare the two. So we say we get the pre-braking velocity, which was up here, and we get the velocity, the angular velocity now, and this is after we've modified it here. We've actually slowed down the spinning of the ball, and that will give us a value. And just to make sure that it's not a negative value, we then use this maths library called mathf, which is for float. And we use the absolute method, and that will basically ensure that the value is a positive number. So, you know, if for some reason the braking value turned out to be -2, it would be 2 instead, because we don't want to be adding on a negative value to our light, because it'll actually make the light go darker, which doesn't make any sense. Okay, so now this is where the bug came from, because it turns out that the basic premise that I had in the beginning, which was that your ball's speed is based on how fast it's spinning, isn't necessarily true, because a ball can be spinning very, very quickly and not actually moving at all. It's basically like wheel spin in a car. So the value that I should really be using to measure my velocity is actually the velocity here, and I should be comparing that, not the angular velocity. Yeah. And it turns out that when obviously you measure that and then you measure it on ice, the marble tends to be spinning very quickly on ice, and because of that you get these really big values and you get this crazy bright glow. Now it turns out that that glow is not permanent. If you wait for a while, it will actually drain away, but I tuned my draining algorithm to work with quite small values, and all of a sudden you've got this massive value, and it just takes a long time for it to drain down to anything that's usable. And of course, if you break again, it's just going to balloon and become incredibly bright again. Okay, so what I'm going to do now is I'm going to just go into this code, and I'm going to swap out this stuff here. You can see commented, and we're going to put in the fix, and then I'm going to demo that to you and show you that it actually does fix things. Okay, so I've made the changes, and in the Player Manager, I've put in the fix code, and in the ball motion controller, you can see I've actually swapped in these values here. So let's have a look in the game now and actually see what a difference we've made by, instead of measuring our braking based on angular velocity, now we're using normal velocity. In other words, how much the ball has moved through space in any given direction. And that should hopefully give us a much better result. Okay, so let's have a look what our code changes have done. I'm just going down and get the brake. Just wait for the glow effect to fade away. And let's see what happens now. So yeah, we get a pink glow. And we'll move along. But now, when we go on the ice, we don't get the pink glow going crazy anymore if we brake. Yeah, so I'm braking. Believe me, I'm pressing the B button and braking away, but it's not having any problematic issues anymore. So there we go. Our code changes have had the desired effect, and our bug is fixed.